Okay, so now we're moving on to costal elements. I'm just kidding, of course. I'm not going to call them costal elements. The term we'll use is ribs. We're going to move on to ribs briefly. We did cover extensively in the last class. Yeah, the fact, I'm not going to spend much more time today, but the fact that if you're not a mammal, pretty much ribs always, always, always point backwards in the neck, and especially in the front of the rib cage. And that affects, of course, where the shoulders can fit on the animal. Mammals are the weirdos that have these ribs that are largely straight up and down up front. Of course, humans, you have to turn them sideways, but it would be roughly the same thing. And it's really a strangeness of mammals, and especially more advanced mammals, the kind we're used to seeing running around today. And rib design has some important function, because like mammals breathe with their bellies. And I'm just going to call it belly breathing. Of course, it uses the diaphragm, but there are other ways to belly breathe. Crocodiles actually breathe with their bellies in a very different way. They, oops, hold on, sorry. They actually have muscles inside attached to their pelvis, which is deeper than a mammal's, and it actually pulls the liver back and then relaxes and lets it go forward to act as sort of a piston. But in both of those belly breathing styles, you need to have areas that don't have as many ribs so that literally your stomachs have room to squish in and out. Because if they can't do that, you'd be pressurizing your guts. And that's a bad idea because fluids, including blood, doesn't pressurize, at least not without a heck of a lot more pressure than you can generate in your stomachs. And so if you do that, you're literally squeezing blood all over in there as everything else contracts, and it could get places it's not supposed to be. It's a mess. You can't have belly-breathing animals that don't have rib-free areas. Everything else, generally speaking, breathes not with the, and if you ever notice movies, you almost always see this sort of breathing going on. Everything else actually breathes with rib motion and no belly motion at all. And there's a little video, I hope this comes through. But usually ribs, this is a modern iguana. The ribs actually move both forward and up. It's going to rotate over so you can see it from the top view now. And it's a huge amount of motion. And of course, the walls of the rib cage are moving sort of all together. And it would have to be rigged and animated really quite differently, and it's the kind of thing that Rhino's first tattoo, well, you gotta love Google and YouTube. It's the kind of thing that you would really want to think about, not necessarily just in your design, but pass along to your 2D and your animator if you want to kind of have a different, more alien look to your creatures. Now this, of course, is advice that matters more if you're going to create a 3D animal or sculpture. But honestly, even when you draw, like very few people seem to ever think about how the breathing works. And yet if you were to paint, I don't know, say, or draw a human being after having exerted themselves, you would, and people do, like say if they illustrate rather heroically Olympic runners, you want to show that belly moving. And if you're designing an animal or an image, even in 2D, of say a predator creature, or heck, let's say a dinosaur or a lizard chasing down some prey, thinking these things through will add a definite level of not just realism, but also drama to the image you're designing. Now, of course, in 3D, you're going to have to leave it up to your animators in 2D to get the drama and the timing down, but helping people, if you're on a team, understand where the motion happens can be really useful for them to take best advantage of your design. Okay, so quick summary here. I apologize for the summaries, but since we only get to cover it once, I figure by summarizing a lot of the information, it will help it stick. So briefly, almost everything on this planet at least has ribs swept back. Even the earliest of animals that aren't yet out of the water have ribs swept back. Mammal ribs are really the weirdos. And really shouldn't be used as the basis, those big solid vertical chests, as designing like non-mammal creatures. Now obviously sometimes you're going to be asked to design a mammal-like animal from another planet, and that's fine. You should definitely choose it because that's a good, cheap way to to get yourself some mammal looking or feeling design. But otherwise, you might want to think twice or even a third time before putting that into your design work for fantasy creatures or alien creatures. Stomach breathing can and has appeared more than once. I told you that modern crocodiles do it. Primitive crocodiles do it also. Obviously, mammals do it. So I'm not going to say you can't make animals stomach breathe at all. Again, I just want you to think about it so it's a conscious choice. And so far, the more common solution on this planet, at least, is to go with rib breathing, in which case it actually has a whole bunch of impacts on like how the rib cage can go together and how it can be designed. We're going to get a little bit more into that later, but I don't want to go too far in depth because we could go too far down the detail road, although I'd be happy to answer questions on that later. A question came up on breathing in a centaur, and this seems like a good place to address that. Boy, have you got me. You could go a couple of ways if you're designing a centaur. You could decide that in actuality, the lungs largely fill up the human portion with, say, the heart, and you could leave most of the other digestive organs to the horse bit, in which case the human torso might have to breathe quite a lot, like really obviously, since it's supporting, well, of course, because the ribs themselves are bigger, but it's also supporting a bigger animal. Might create for a pretty interesting dynamic. Certainly if your centaur was chasing something and it stopped because it couldn't catch it, I guess it would really demonstrate the it's out of breath, it was trying hard to catch it scenario. A lot of people seem to just tack it right on, you know, with the human and the centaur, and they seem to have like the same human guts in the human portion and horse guts in the horse version. And that's maybe fine for like how you digest food. That would be a huge mess though from a realistic design point of view for breathing. You pretty much have to have the lungs one or the other. And I will say this, the longer the tube is between your mouth and your lungs, that tube is called the trachea, if any of you want to know, the longer that tube is, the bigger problems breathing you have. You have to go to a whole bunch of other specialized solutions to get around that unless you have a bird-like air sac system, which of course mammal-like animals do not. Okay, a little bit more rib cage design. If you are going to go with a stomach breathing animal, remember that they need to have soft stomach areas. You got to have some areas where you don't have ribs. Don't give them armor or ribs going all the way down on the sides or the fronts of the bellies. Somewhere they've got to have room for the belly to expand and contract. And I mean this, if you work in the sort of integrated office where you're not just passing your design off to another company, but actually have a whole pipeline, you know, talk with the other people in the pipeline. You know, how good your work, if you're doing digital sculpting for TV or movies, how good your design works on screen isn't just dependent on how good of a designer you are, although that's a really big part of it. It's also dependent on whether it's shown off to its best. You know, is it in the right light? And sharing some of these insights can possibly help the team maximize the effectiveness of your design, and it really makes their job easier and better too, because they don't spend as much time tinkering or maybe even resculpting parts to make it, quote, work when they start trying to make it do something it's not intended to do. Okay, so I said we get to the hips, and we will, but there is one more part of the backbone we got to talk about. It's a really important part in non-mammals, and it's this blue part here, the sacrum. We'll just say the hip vertebrae, if you prefer. This is another one of those areas where mammals are not weird, but they are very different from dinosaurs. Mammals, generally speaking, only have 2 vertebrae attached to the hips. You know, humans is literally hidden behind there. Some mammals have 2.5, where 2 of them kind of grow together and help support it, but it's not very many. You know, in this long, sorry, in this mountain sheep, you can see that even though it's got an elongated sacrum, which I'll show you here in a second top view, only a little part of it's attached, whereas the dinosaur attaches multiple vertebrae. In fact, one of the ways you can tell if an early dinosaur-like critter way at being in the Mesozoic is in fact an actual dinosaur, is they start adding vertebrae into the pelvis right away. Now you can imagine for designing big animals why this is a pretty good thing. It's because it lets all the force being generated in the legs transfer right to the backbone, or if you want to think about it in reverse, all the weight being carried down here, especially if the animal is being active, is transferred very, very securely right to the parts of the animal that are supporting it. Okay, this is a deer pelvis in top view. I'm seeing some good questions coming up. If you guys could save these ones probably for the Q&A that'll be coming up in just a little bit. This is the pelvis in top view. As you can see, this is that elongated sacrum area that I colored in blue on the mammal. And you can see this is the only part of it that actually attaches to the pelvis. That is literally all that is holding on in terms of bone. All the force of the hind legs are generating to the pelvis, or to the back, or vice versa. This is probably, oh, here's a bird. Bird pelvis in side view, bird pelvis in top view. The vertebrae are all fused. There's like a dozen or more in there. Each of these holes actually is kind of between some of the fused ones there. But even without knowing the number, you can see how it's completely fused front to back and how much of the backbone is supported right with a physical bony connection to where the legs, do their work. Okay, so hips. Your hip might be really well attached to your vertebral column. It might not be. They have to work either way. So let's do a little bit of an understanding of hips. If you look at both flex-limbed, more active or dynamic animals, and then more elephantine-limbed graviportal animals, you'll see that you have the exact same patterns. Elephants still only have a couple of attachment points, whereas the big sauropods, which are dinosaurs, have 5 or 6 incorporated in there. So this is a reoccurring thing. And by the way, probably sauropods, despite getting much bigger than elephants, there's no functional reason to think that they weren't actually more active. I don't mean more active like running. They don't have the right legs for it, which we'll talk a little bit about this week and more next week. But there's no reason they couldn't survive, say, crashing into something with more force than an elephant, even when they're the same size. And if you've ever seen what an elephant can do to like a parked car, you'll know that that's actually quite a lot of force we're talking about here. Now this is a dinosaur thing. If you look at crocodiles, and even the more primitive ones, you rarely see much in the way of affixing, if you will, more vertebrae to the pelvis. There are some limited experiments with some of the crocodile archosaurs, but by and large you can assume it's a dinosaur thing. Now, does that mean it's a strange thing that you shouldn't see everywhere else? I'm not so sure about that, and here's the brief paleontological reason why. Pretty much you only get 2 great radiations of large charismatic megafauna that are also particularly large and active. That is, let's say, get above a ton or 2 and are active. You really only get dinosaurs and mammals. That is, you only have a sample size of 2, and dinosaurs do this multiple times independently. In meat-eating dinosaurs, in sauropods, in duck-billed dinosaurs, and the horned dinosaurs, and in the armored dinosaurs, that's 5 different times within dinosaurs, you see them independently add more of these vertebrae from the back and occasionally even from the tail into the pelvis to make the attachment better, which suggests that really it's a pretty easy, pretty common solution to come across, whereas mammals, which of course started with that 2/3 of their history being small, may simply have trapped themselves into not being able to kind of overcome ancestral genetic programs, which might be why they don't do it. So with a sample size of 2, you still see it happen 5 times independently. So I think if you're going to design the next, if you're working on Avatar 2 or whatever, and you're designing new big animals for your world, I think it's not unreasonable to, if it works for your design, to go ahead and add more of those vertebrae into your hips, make the hips bigger and longer as a result. And it works really well with a big, heavy tail if you're going to go that direction. The other thing, of course, about making your sacrum bigger is, by definition, your back is getting shorter. And we've already talked about how big animals on land like to shorten and stiffen their backs a little bit anyhow. Okay, let's understand the hips a little bit. So here's a human pelvis. And looking at a dinosaur pelvis, it's easy to get lost and say, that's really strange. It looks nothing like what we have. How do I think about it when I design it? But it turns out it's not really as crazy different as you might think if you look at them both in front view. So this is kind of the front view of a human pelvis. This is down, that's up. There's, of course, the coccyx. This is the part that you break if you sit down too hard. This is the front view of it's not actually a dinosaur pelvis, but it's a relative, and it's constructed roughly the same way. And here's what you see. Vertebrae, vertebrae. Here's what we would call our hips when we're putting our hands on them. That's the ilium. Those are the bones that mostly support the upper leg muscles, and the leg muscles mostly are on the outside, and here they're entirely on the outside. And then you have this bowl that the guts go right through, and then you have two sets of bones. You have the pubic bones and the ischial bones, and you have the same thing. In front of you, you can only see the pubis because they're large here, the pubic bones on these guys, and it blocks the view, but the ischia are still back there. They're still making the same portion of the bowl. It's just that then they're drawn down to where they can do other things. Now in side view, once you start elongating those bones, you will see a lot of crazy things happen if you look at the fossil record. Dinosaurs are sort of famous for having two quote-unquote main groups based upon their hips. One has a sort of primitive condition with the pubic bones essentially straight down and the ischial bones at different degrees of backward pointing, depending on the group. Whereas another group of plant-eating dinosaurs that split off early on takes this other route, which superficially looks more like what birds do, although birds end up doing it sort of differently. But in this case, what they've done, all they've done is they've taken that pubis and it's moved slowly backwards, like this. And if you're looking at going, well, that's weird, why would they do such a thing? The answer is sort of simple. These guys, which were all devoted plant eaters early on, lots of specialized teeth, which would have made it very hard to eat any meat hardly at all, needed bigger guts, and they're still walking on two legs. And the neat thing about swinging this back is it lets the guts not stop here and then have to go down to exit out the, well, you know, where things exit. Instead, there's a lot more room now for the guts to fill up in, all those intestines and stomachs and stuff, before coming back up and then going out. So basically, if you mess with your pelvis this way, you're increasing the size of the gut. You're getting free storage, if you will, without making them more front-heavy and two-legged animals. There's a great question that came up about two-headed creatures and spine and pelvis design. In a way, we can answer this pretty effectively because, of course, there are the occasional accidental mutated conditions in embryos, or sometimes intentionally in labs with things like fish, where they create two-headed designs. And the short answer is it's pretty hard. And most of them die, but you have gotten two-headed snakes, some two-headed lizards, and some other organisms that lived, at least for a while, and a couple of them seem to have lived much of their normal lives. And it seems that what literally happens is usually right around the shoulders and the ones that survive, you have a split where you have an odd sort of wedge-shaped vertebrae that's wider on the front, and it supports two vertebrae coming right off of it, almost like if you were going to just play with silly putty how you would think you would design it. And then the muscle origins have to split as well. And so it actually, to be honest, it almost looks fake. It's not fake, but it almost looks that way because you have this neat little crease sort of in the muscles between the two heads of the vertebrae. But you know, it does give you that freedom if you're coming up with a two-headed or hydra-like animal to go ahead and be like, well, the muscles are coming up. You still want to see the muscle definition, but they just kind of end at this crease there because that's what seems to happen in real life when you get two-headed animals. The red is the ilium, I-L-I-U-M. That sort of all the information about what the names of the bones are and stuff Oh, that does say Ilion. That is misspelled. Ignore these. All the actual names are going to be available in the actual resources I hand out. So, okay. So let's kind of finish up on bony butts here so we can move on to other items. Big creatures are going to be able to take advantage of those big hips if you choose that. Again, if you have your big hypothetical creature tearing through a steamy jungle on another planet, chasing the heroine down, big hips obviously mean more leg muscles, obviously means a more powerful energy source for the animal to chase the heroine with. It also, of course, allows you to take advantage of those big muscular tails. It does automatically create slightly shorter and stiffer backs. If you're wondering why it makes the back stiffer, it's just because if you have less vertebrae, there are obviously less points to move. And so even if you change nothing else, with less points to move, the back is automatically a little bit stiffer already. And finally, oh, I already mentioned this. If you give them those heavy muscular tails, it goes really nicely with a sort of dinosaur-style hip. Now, I don't mean you have to make a dinosaur out of it, but that kind of elongated hip that's well attached to the pelvis, maybe with backbones that come up well above the hips if you want to, like, open up your design options. Those all go really well with heavy muscular tails and let you design large, active animals that probably would surpass the activity levels we've seen in big mammals today. Now, in side view, we looked at the hips. Those lower elements obviously vary a heck of a lot. If you're making a big gutted plant-eating animal, it doesn't hurt to try to like move them towards the back to get out of the way. But I did want you to understand that they're always the same 3 bones on each side. So you don't have to freak out and be like, gosh, these things are really different than the hips. They're really more similar to human pelvis or any other set of pelvic bones than you would imagine from your first look at them. And especially, as I showed you in front view, they all have to function the same way. They all have to let the guts go ahead and pass through to the back end, shall we say. And we really covered this. Dino hips. Oh, yeah, no, I didn't cover this. If you're going to have a big, well-muscled set of dinosaur-style hips, dinosauroid hips, having deep pelvic bones is probably key. And the reason I bring this up is if you look at Jurassic Park, they made there should be stuff hanging down here. And I understand why they didn't want the pubic and the ischial bones to extend down a bit. They're always afraid that the 4th grade boys will point and laugh at it when they see it. And that's understandable. But there are ways to design them so that even though they're there and perhaps project a little bit, they are more smoothly associated with it, especially on the tail now. It looks like big, heavy tail muscles often cover much of the length of the ischium that comes down. Oh, let me go back. One thing, though, in general, and they sort of missed this in their attempt to like not have 4th graders laugh. Animals with deep pelvic bones, even if you don't want to show them, if your director's like, we can't have that hanging down there, it will get a PG-13 rating in our kids' movie. Even if you have to make that sacrifice, there is one important design change compared to mammals that will entail, and this is for a lot of things. It narrows the hips on the bottom side. The stomach, as big as it is, even in things like sauropods that have gigantic distended stomachs, because they have the large, deep pelvic bones there, it narrows up right as it comes into the legs. So you have these big, rotund bodies that get narrow and go through the legs, which lets the legs be closer together when they move, which is actually a good thing because active animals on the ground who are fast actually tend to have their feet fall closer to the midline because you get a more direct transfer of force from the leg into the ground. Okay, this is a great point to stop and take more questions before moving on to our final topics for today, before looking at some ZBrush goodness and discussing some things you could do.
All right, guys, that's a lot of information. So if anybody wants to, has their mic hooked up and wants to actually ask the questions directly, raise your hand. That's in the interface on that little extra little dial to the side of the control panel. You can just raise your hand and I'll see it. Otherwise, type in your questions. Now, I'm writing down all of these notes. I hope you guys are writing all of these notes down as well. But as Scott mentioned, they're going to be available to you as well as the reference drawings. So I want to ask a couple of questions, Scott. The pelvis, when you say deep pelvic bones, you're talking from a side view, the front bottom to top is what deep means, right? Or do we mean, yeah, exactly.
Yep, you're absolutely correct. I mean this large, tall base for some of the leg muscles and stuff to work off of.
Okay.
And the result of that is there's nothing in between them, so that's why it gets narrow in between the hips. Even if you're going to hide this, if you're going to make the stomach come down that high, you're still going to have a shape change from the big, broader stomach to the narrower part between the legs.
All right, and then that provides some room for really beefy adductors for the legs, right?
It does, and it allows them to have beefy adductors and still have the legs relatively closer to the midline. You know, they don't have to be sprawled way out to the side. They could be if you wanted, but they don't have to be. You have that room.
Now, are there, let's say, for example, with these dinosaurs, are their knees pointing out? Like, say, a horse has a little bit of a pointing out, or are they pretty straight up and down?
Yes. No, actually, pretty much all dinosaurs and pretty much all land animals have the knees, who are upright, I should say, have the knees canted outward like that a bit.
Mm-hmm.
And actually, in most dinosaurs, the flex limb dinosaurs, it's actually more than horses do. Not by a ton in some of them, but it's a little bit more than like horses or rhinos do when they're walking around like that.
All right. And does that bring their ankles, you know, much closer together from a back view, or?
Yes, that makes knees out, ankles in is actually one of the mantras of building dinosaurs, and would apply for using dinosaur-like legs in a creature. Yep.
Okay, and then the inverse applies for the front limbs, right? The elbows are out and the shoulder is in.
Correct.
Okay.
We'll be getting more to the chest and why that is in the next section, but you're absolutely right.
Okay. All right, so somebody's raised their hand. Isan, you took your hand down. All right, nobody's raising it, but we do have a couple of questions. Okay. Brooke is writing, but you've got something from Wilda, and then there were some previous questions from Roman about, I think you already talked about multi-headed creatures, though. So.
Okay, let me take these out of order because the how come dinosaurs have no lumbar vertebrae is actually easier to answer. It actually relates to that belly breathing we talked about earlier. Lumbar vertebrae, their sole purpose is to not have ribs, basically. So that there's room for the stomach or the sides to expand and contract during breathing. Now, the funny thing about that question is there are some dinosaurs, including the ones we're looking at, that don't have lumbar vertebrae, but they actually have sort of a lumbar region where the ribs get out of the way, which suggests that in these groups of dinosaurs, they might use a hybrid with some rib motion, but also some expansion and contraction of the stomach. In fact, there's even been a suggestion in these cases that their elongated ischium, that's this bone right back here, might itself move because the connection here is not as solid as it looks, might move slightly forward and back, which would be a really fascinating and sort of really unusual way to show an animal out of breath if they're going and like kind of the back of them underneath their tail is also like moving forward and back as the whole thing expands and contracts. Let's see here. Do human ribs? No, human ribs really are still pretty vertical. You just got to take humans and remember that whole planking craze? You got to go plank a human to get them into the same anatomical position as like most other animals. So the thing about mammals and rib breathing is all mammals do rib breathe to some degree, but we tend to tie up our ribs much more tightly with our sternum, so it's much less effective. Sort of the whole thing has to move. In people who have their ability to stomach breathe taken away, that is, they get the diaphragm damaged or detached or something, they don't asphyxiate. They still breathe with their ribs. However, it is a more labored process since we're now kind of dependent on belly breathing, and like people with detached diaphragms do not run marathons, for example. So we do have our rib cages move a bit, and you can feel it moving, of course, when you inhale or exhale. But of course, part of that, if you're sitting down, is your back is actually expanding out the back to the lower back of the lumbar, so you push yourself away. But to some degree, your chest moves a little bit, but nothing like what you see in rib breathers. Okay, now going back up, because I don't want to miss the chimera question. That would not be fair. That's a really good question. I have not thought a lot about chimeras. If you wanted to design a biologically plausible animal with a head coming out of or neck and head coming out of the back, I think you would have to treat it essentially as a two-headed animal where one of the heads migrated back. You might even have a weird little curve to the spine where the split took place, like have the split a little in front of where the head comes out of the back. And as a result, it might actually be easier if you could have the head look off to one side, like you could have left or right-handed or left or right-headed, I guess, chimeras. And then you'd be able to design back muscles and neck muscles around that. I think on the fly, without spending a lot more time drawing things on a paper, that's the best I could come up with for a biologically plausible chimera. That's a really good one. Let's see whether there are other questions up above. Oh, the question about the multi-headed creatures breathing, like the Hydra from Hercules. Since hydras all have to make noise or whatever they're doing, that means that they're all going to have their own tracheal tubes connected presumably to one set of lungs. As a result, I think a really interesting thing would be for them to, especially if they're mouth breathing, which if they're all active and stuff, you know, chasing Hercules are going to be, I think it would be really interested to make the design choice to either have one or two of them really kind of gasp for the others. Like some of them could be mouth closed trying to find where the hero is hiding behind a rock or something, and the other ones are like actively for them. Or else, if you wanted a more rhythmic, perhaps more sophisticated, less primitive look, you could have them all sort of opening in unison to breathe, because of course the chest cavity is going to have to ventilate, that is expand and contract, sorry, the same pair of lungs at the same time. So whatever your solution is, you're going to have some coordination between the heads. I suppose if you wanted to make it a design feature, you could design one head that was more mouth and less used for other activities whose sole purpose it was to breathe, and that would sort of free the others. But since hydras, like in mythology, of course, tend to like grow heads really quickly when you lop their heads off, I don't know if that's the best way to go. I think you're better off going with making a couple or all of them breathe in unison as they need to inhale and exhale. Some really great questions tying this back to mythological and fantasy creatures. Okay, anything else before I move on?
There was one question about front views. So Remy was asking about getting front views of the drawings or any common rules that can be applied so that, you know, when we're looking at your side views, we're also able to extrapolate out a front view.
Yeah, I want to hit up front views here in a little bit, actually. We're heading towards shoulders more or less directly. And also I will, in the packet of available things, I'll include some front view. Of course, there are the ones in this slideshow you could look at if you watch the video, but I'll include some skeletal diagrams of at least dinosaurs in front view. And then I'll have a list of rules coming up, general rules. So, tracheal sacs and the relationship to animal sounds. That is unfortunately, I think, too broad of a subject to answer without like having its own section in the class. Certainly, adding resonating areas, expandable throat pouches and stuff is something you see happening again and again, as well as inflatable nose crests. So those things definitely happen and can affect sound. However, like a lot of the lion's roaring is a fairly specialized feature, and there's so many of those, I don't know that I can really go into them with much detail without having slides and Yeah. So in short, I'm going to say no for this. Not because it isn't important, but because I think it's one of those topics that would have to almost have its own class, or half a class or something. It's a really good question, though. Okay, well, we'll move on then. Ooh.
Just got a few more questions pop in there, guys.
Yep. Okay, a question about how many vertebrae are there in front of the hips, basically, the presacral vertebrae, as we would refer to them in the literature. That's a really good question. 24 is a pretty decent starting number. Really primitive dinosaurs end up with like 9 neck vertebrae also, including the atlas axis in there, and then fairly long backs initially. And so 24 is not, I don't know if there's 15 of them, but there's like 14, so 23 vertebrae, and several of them. Now, of course, that does get shortened in several lineages independently, especially ones that get bigger as they further stiffen up their backs. So if you're designing alternative Earth-based creatures, that's still a really good number, and then you can kind of consciously be like, but I want to expand the hips quite a lot and cover 3 or 4 more backbones roughly. I don't mean you have to, and if you're drawing a skeleton, you can do this literally. You can say, hey, I've kind of sketched in a rough spine, and now I want the hips to cover this much more. And I think 23 or 24 is a perfectly good place to start if you do that. Of course, if you're going to be on other planets, you could have very different starting points. You could have shorter or longer backs in theory. The same principles will apply, but you would quite probably have different design numbers coming up. The mouth membrane. Do you mean the part of the throat that kind of closes off in the back so that they can like attack or otherwise open their mouths underwater? Roman? Let's see, we'll wait for him to do. Oh, you mean the web that looks like cheeks that you see inside of you in the back? Oh, that's a really good question. We'll talk more about heads next week, but the short preview answer is those are actually jaw-closing muscles. Like if you think about it, and you see older dinosaur pictures where people didn't think about it, they'll have the mouth go all the way back like to the hinge, as if it's like a continuous grin without that. And those types of very wrong reconstructions would not be able to close their mouths. You have to have the jaw-closing muscles in front of the hinge. And so no matter how much you don't have traditional cheeks, you have to have sort of an area that's cheek-like where the muscles come down in front of the hinge, and that's all that is. It's just some flesh covering the jaw-closing muscles. Yeah, like in this case, you have this here being shown, although that might be expanded to partially be the onset of mammal-like cheeks, too, in this little proto-mammal guy. Yeah, that's a really good question. And in several dinosaurs, that actually moves up, and of course, eventually may become more fleshy cheek-like structures. We'll definitely discuss that in more detail next week, I promise. And someone wanted to know if they could do 3 spines in one pelvic base. That would be like essentially 3 vertebrae with spines coming up, and that would be totally plausible. That would be like kind of just a super mammal or a really early dinosaur, essentially. Totally plausible. Okay, we'll take questions again towards the end before we transition to ZBrush stuff. So let's, I think, move on right now, if everyone's okay with that.
Sounds good.